This is First Coast Math Clinic with Lesson 3 Pythagorean Theorem from Unit 11 Triangles from our Pre-Algebra and Algebra curriculum. So the goal in this video is to use Pythagorean's theorem to find the length of unknown sides of a right triangle. So let's start just by reviewing what a right triangle is. So I can identify a right triangle because where our legs meet, we get a right angle. So our right angle is denoted by a right angle square. So it's right here, right? And then the two sides that meet to form that right angle are the legs, and the side that's across from the right angle, that's our hypotenuse. And Pythagorean's theorem is going to be leg squared plus leg squared equals the hypotenuse squared. So if we square the legs, add them together, we're going to get the hypotenuse squared. So let's go through that relationship when we have some actual measures here. So let's say that our legs are 3 and 4, and that hypotenuse is 5, just illustrating what this relationship looks like. So we've got this leg is 3, so I'm going to put that leg here. There's some substitution. This leg is 4, and the hypotenuse here is 5. So our substitution, we're going to have 3 squared plus 4 squared equals 5 squared. So when we simplify this, we've got multiplication, we have exponents and we have addition. We're going to do our exponents first. So 3 squared means 3 times 3, so we're going to get 9, plus 4 squared, which is 16, equals 5 squared, which is 25. And then 9 plus 16 is going to be 25, so we get 25 equals 25. And the left side and the right side are equal to each other, right? So it shows that when I square the legs, add them together, I get the square of the hypotenuse. So I can use this relationship to find missing legs and missing hypotenuse for any right triangle. All right, so let's go through some examples where we use Pythagorean's theorem to find missing legs or missing hypotenuse for a right triangle. Okay, so let's look at triangle number 1. 6 is a leg, 8 is a leg, and x is a hypotenuse. We know that 6 and 8 are our legs because they meet up to form the right angle here. And we know that x is the hypotenuse because it's across from that right angle. And the hypotenuse, that's our unknown. So that's what we're going to be solving for. So Pythagorean theorem is going to be leg squared plus leg squared equals hypotenuse squared. So let's substitute our values in. Now it doesn't really matter which leg we make which. So we can substitute 6 and 8 into each one of our legs, and then x is our hypotenuse, so let's do our substitution. So we'll get 6 squared plus 8 squared equals x squared. Now, order of operations, we've got addition and exponents. We want to do the exponents first, so we'll get 36 plus 64 equals x squared, and then we get 100 equals x squared. All right, so let's do the rest of this up here. 100 equals x squared. Now, if you watched lesson 2 on simplifying square roots, I made a video on how to handle equations that look like this and how to simplify a lot of the problems that we're going to get into in this video. So if you're have questions on this stuff, you can check out lesson 2. Links can come for the video for the video for lesson 2 right now, as well as at the end of this video. But basically, we want to know what x is, not x squared. So we need to undo this operation of squaring. Well, what operation undoes squaring? That operation is taking the square root. So I'm going to take the square root of the left and the right side. Squaring and square root undo each other, so we get x equals the square root of 100. Now, we know that from the previous video, we know that the square root of 100 is equal to positive 10 and negative 10. All right, because 10 times 10 is equal to 100, and negative 10 times negative 10 is equal to 100. But let's think about what we're asking, right? In this question, we want to figure out, well, what is this physical distance? Because x is this physical distance. And when we're solving for x, whatever our answer is going to be that physical distance, right? So it's either going to be 10 or negative 10. Now, one of these answers is not really too reasonable, right? If our answer is a physical distance, our answer has to be positive. It can't be this negative distance, right? We can't have a negative distance or a negative number as our distance. So we're going to discard, when we get an answer like this, we're going to discard the negative answer, and we're going to keep that positive value as our answer. So we got two answers here, positive 10 and negative 10. We know that since our answer has to be a distance, we have to keep the positive answer. So our x is going to be positive 10. For number 2, our legs are 12 and x because they meet up to create the right angle. Our hypotenuse is 13. So using Pythagorean Theorem, leg squared plus leg squared equals hypotenuse squared. Substituting our values in. So we'll do 12 squared plus x squared equals 13 squared. So in this example now we're solving for a leg, not the hypotenuse. So this equation is going to look a little bit different, right? So x and 12 are going to be on the same side. So now when we solve this, let's square the 12. We get 144 plus x squared equals 169. Subtract 144 and 144 because you want to get the x squared by itself. We get x squared equals 25. And we're going to do the same thing here that we did right here with example 1, right? So we're squaring x. We want to undo squaring x. So let's take the square root and square root. So we get the x squared and the square root cancel each other out. So we get x equals the square root of 25. Well, what's the square root of 25? From the previous video, lesson 2, we learned that the square root of 25 is going to be positive 5 and negative 5. But if our answer is a physical distance, or at this length, our answer can't be negative. So we're going to discard this negative answer and keep this positive one. So our answer is going to be positive 5. Okay. All right, let's get into a couple more examples where we use Pythagorean's theorem to find missing side lengths and hypotenuse lengths for right triangles. Okay, so for number 3, we've got our legs at 3, 3, and our hypotenuse at x. So our Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So let's set this up. We can have one leg is 3, second leg is 3, and our hypotenuse is going to be x. So let's do our substitution. We'll have 3 squared plus 3 squared equals x squared. 3 squared is 9 plus 9 equals x squared. 9 plus 9 is 18 equals x squared. Well, I want to know what x is, not x squared, so I'm going to take the square root and square root of both sides. I remember we did this in lesson 2, so I'm going to post a link to lesson 2 at the end of this video if you want to review how we solve these problems or simplify these problems and more problems like this. So the square root of x squared cancels out, so I just have x equals the square root of 18, but 18 is not a perfect square, so we need to simplify that a little bit. We could break this up. So what I'm going to do is I can break this up into the square root of 9 times the square root of 2. And I chose the square root of 9 in particular because 9 is a perfect square. Nine and 2 are my factors of 18. So the square root of 9 is going to give me 3. I'm going to keep the positive answer. So in the last video, we said our square root is positive and negative. And because we're finding a length, all right, this is a distance. Our distance can only be positive, so we're going to keep our positive answer. I can't do much with the square root of 2. If I take a square root of it, it's going to be a decimal. I don't want a decimal answer. Factoring the 2 into 1 and 2 doesn't help me, so I'm just going to keep the square root of 2. So my answer for x is going to be 3 square roots of 2. And that's going to be our answer for x. That's going to be our exact answer. So this is our exact answer. Now, if we wanted the approximate, well, we could take our square root of 18 and just plug it into our calculator, and we'd get 4.24, and round it to the nearest thousandth, because it'd be 4.2426. So if I'm rounding that 2, looking at the 6, I'm going to round that 2 up to 3, and I'll get 4.243, or 4 and 243 thousandths. So once I round my value, it's no longer exact, it's an approximate, right? So we have two answers here. We have our exact value here, and we have the approximate value here, okay? All right, so let's look at number 4. So number 4, our leg is x, leg is 2, and the hypotenuse is 7. So Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So let's do our substitution. Hypotenuse is going to be 7, so let's replace those values. So we'll have 2 squared plus x squared equals 7 squared. 2 squared is 4 plus x squared equals 49. Let's get the x squared by itself, so I'll subtract 4, 4 cancels out on the left. I get x squared equals 45. Now we're going to do the same thing we did here. All right, I want to know what x is, not x squared. So to undo squaring, I'm going to take the square root and square root. So I'll continue this over here. The square root of x squared cancels out. I'm left with just x equals the square root of 45. Now, 45 isn't a perfect square, so let's factor into two numbers where one of the numbers is a perfect square. Well, what are some factors of 45? We've got, what about 9 and 5, right? 9 is a perfect square. Square root of 9 is positive 3. Square root of 5, 5 is not a perfect square. I can factor into 1 and 5, but that doesn't help me, so I'm just going to keep the square root of 5. And this is my exact answer, 3 square root of 5. So this is my exact value. Okay. Now, if I wanted the approximate, we could just plug this into the calculator. And we take the square root of 45. And we get 6 and 708 thousandths. The entire decimal kind of extends after that. It's like 6.70820, but it's like a 2 0. If I'm rounding to the nearest thousandth, I'm looking at that 2. Since it's lower than 5, I'm going to keep that 8 as it is. So my decimal is going to be 6 and 708 thousandth. Right, so we've got our approximate answer here. Right here. And our exact answer right here. Okay. All right, let's go through a couple more examples finding missing legs and hypotenuses with Pythagorean theorem. Number 5, our legs are the unknown. We've got x and x for the legs, and our hypotenuse is 12. So again, Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So again, it doesn't really matter where we put in the x and the x. Those are our legs, but the 12 is going to be our hypotenuse. All right, so let's do our substitution. So we'll get x squared plus x squared equals 12 squared. So when we simplify this, the coefficient number in front of these x's are 1, right? So 1x squared plus 1x squared is 2x squared, and then 12 squared is 144. So we want to get the x by itself. So first thing I want to remove from this left side is going to be this 2 right here, right? So I'm multiplying by this 2. So to undo multiplying by 2, let's divide by 2 and divide by 2. 2's on the left cancel out. So I get x squared equals 72. Now I'm squaring. So to undo squaring, let's take the square root. Take the square root. Square root and square cancel out. So I'm left with x equals square root of 72. So now I want the largest perfect square that goes into 72. So let's think of our factors of 72. Let's factor out 72 up here. Some more factors. Well, we've got like 9 and 8. Okay. We do any better, maybe we've got like 4 and 18. Okay, so 9 is a perfect square, 4 is a perfect square. Let's see if we can do any better, right? So we want the largest perfect square that goes into 72. What if we do 2 and 36, right? So 36 is going to be the largest perfect square. That's a factor of 72. So let's do these two factors, 2 and 36. So let's break this up. Square root of 36 times square root of 2. Square root of 36. So I do this over here. We know our square root of 36 is going to be positive and negative 6. All right. But since we're talking about a physical distance, all right, we can't move a negative distance. So we're going to discard the negative value, the negative length, and just keep the positive answer. So we're just going to keep the positive 6. So we're going to have positive 6. Now, square root of 2. Is approximately like 1.414 and continues on from that, right? Well, I want the exact answer, right? So I can't write down the entire decimal and I don't want to round that decimal value. So to get the exact answer, I'm just going to keep that square root of 2 and multiply 6 times square root of 2. So this is how I'm going to write my answer. X is equal to 6 times the square root of 2, right? So that's going to be my answer for the leg, 6 times square root of 2, and that's my exact answer. And if I want the approximate answer, I can just plug this into the calculator, take the square root of 72, and if we want to round to the nearest thousand, well, that 5 is in the thousandth place. Let's look at the 2. It's lower than 5, so we're going to keep that 5 as it is. You can get rid of all these other values. So we get 8 and 485 thousandths as our approximate answer, right? So this value right here is our exact answer, and this value right here is our approximate because we had to round. All right, let's do one more example where we use Pythagorean theorem to calculate the legs and hypotenuse of a right triangle. Okay, so for number 6, we've got our legs at x and 4 square root of 3, and our hypotenuse is 8. So again, Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So let's substitute our values in. Our leg is x, leg is 4 square root of 3, and then the hypotenuse is 8. So we'll get x squared plus, not equals, plus, I'm going to put this in parentheses, 4 square root of 3 squared equals 8 squared. So I'm going to get x squared plus, I'm going to do this off to the side just to show you how to do it, equals 64. So we've got 4 square root of 3 squared. So the way we're going to do this, we're squaring the 4 and the square root of 3. So the way we're going to do this is we're going to square everything in here. And let's think about what that means, right? So if I'm squaring like 2 squared basically means like 2 times 2. So 4 square root of 3 means 4 square root of 3 times 4 square root of 3. Well, let's group together what we can easily multiply. Well, we can easily multiply 4 and 4. So 4 times 4. And what about the square root of 3? Square root of 3 times square root of 3. Okay? Well, what's 4 times 4? 4 times 4 is 16. And what's square root of 3 times square root of 3? Square root of 3 times square root of 3 is square root of 9. And I keep doing as we do this over here. So I'll get 16 times, well, what's square root of 9? Square root of 9 is 3. And then 16 times 3 is going to give me back 48. Okay? So that's basically what we're doing here. Another way to think about this is we're squaring the 4. So we're squaring the term outside the radical. And then we're squaring the term under the radical. So 4 squared is 16. Square root of 3 squared. The radical and the exponent cancel out. So we get back the 16 times 3, which gives us 48 as well. So both ways we get 48 here. Okay, let me clean this up a little bit. So we've got x squared plus 48 equals 64. So let's get the x squared by itself. Subtract 48 and 48. We get x squared equals 16. Now I want to get the x by itself, so I'm going to take the square root and square root, undo squaring. The square root of x squared is x equals, and the square root of 16. Now again, from the previous video, we know that the square root of 16 is going to give us positive and negative 4, but because we're looking for a physical distance here, right, we can't travel a negative distance, so we're going to discard that negative answer, right? When we get positive 4 and negative 4, well, we can't travel a negative distance, so we're going to cross out that negative answer, just take the positive one, because the negative answer is not a reasonable one, and our answer is going to be positive 4. So x is going to be positive 4 here, okay? All right, so this video was lesson 3, Pythagorean Theorem, from our Unit 11 triangles. I hope these videos are helping you guys. If you like these videos, leave a like, comment, and subscribe. First Coast Math Clinic.